Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. We are doing NEET series where we are doing the SMART study. That is, we are solving previous year NEET questions. We've already covered P block elements group 13 and 14. If you have not watched that video, then please do. I'll give the link in the description box. In this video, we will cover questions based on group 15 to 80. This is part 1. While solving these questions, you get to know the important trends and exceptions in P block elements. So whenever you come across such questions, just pause the video and take a screenshot or write down the trend. It's a great way to cover all questions that may come in the NEET exam. If you have not subscribed to my channel, then subscribe now and press the bell icon to watch my videos at the earliest. Also like and share. Which of the following statement is not true for halogens? So all but fluorine show positive oxidation states is not true because fluorine shows positive oxidation state in HOF. Match the interhalogen compounds of column 1 with the geometry in column 2. So XX dash is linear, XX dash 3 is T-shaped, XX dash 5 is square pyramidal, and XX dash 7 is pentagonal bipyramidal. Nitrogen dioxide and sulfur dioxide have some properties in common. Which property is shown by one of these compounds and not by the other? A. Both are soluble in water. B. Is used as food preservative. C. Forms acid rain. And D. Is a reducing agent. So sulfur dioxide is used as a food preservative, but nitrogen dioxide is not used. So option B is the correct answer. Which of the following statements is not valid for oxoacids of phosphorus? Orthophosphoric acid is used in the manufacture of triple superphosphate. It's correct. Hypophosphorus acid is a diprotic acid. Is not correct. It is a monobasic acid. All oxoacids contain tetrahedral. 4-coordinated phosphorus is correct. All oxoacids contain at least one P double bond O unit and one POH group is also correct. So option B is the correct answer because it is the incorrect statement. In which pair of ions both the species contain SS bond? So we write down the structures of the species: S4O6 2 negative, S2O3 2 negative, S2O7 2 negative, S2O8 2 negative. So S4O6 2 negative, its structure is S double bond O and single bond O negative, and then sulfur linkages. So it contains sulfur linkages. S2O3 2 negative also contains sulfur linkages. So option A is the correct answer. Whereas S2O7 2 negative does not have any sulfur linkage. S2O8 also has a peroxo linkage but no sulfur linkages. So these options are not the correct answers. Option A is the correct answer. Match the following compounds in the given column with the hybridization and shape given in column 2 and mark the correct option. So XCF6 is a distorted octahedral. So option A is matched with option 1. XCO3 is pyramidal. XCOF4 is square pyramidal. And XCF4 is square planar. You can see XCF6 is distorted octahedral, XCO3 is pyramidal, sp3 hybridization, but one of the position is occupied by a lone pair of electron. This XCOF4 should have been octahedral, but because one lone pair is present in one of the positions, so shape is restricted to square pyramidal. So XCOFR is square pyramidal. XCF4 is square planar because two of the octahedral positions are occupied by a lone pair of electrons. The hybridization is sp3d2. Which is the correct statement for the given acids? Phosphenic acid is monoprotic while phosphonic acid is diprotic. This is the correct answer. We get to know the answer from the structure of phosphenic acid or hypophosphorus acid. It has only one OH group, so it is monoprotic or monobasic. Whereas the phosphonic acid or orthophosphorus acid has two OH groups, so it is dibasic or diprotic. So option A is the correct answer. Which one of the following orders is correct for the bond dissociation enthalpy of halogen molecules? So down the group, the order is fluorine, then chlorine, then bromine, then iodine. So iodine is the biggest atom, so the bond is longer, so it can be easily broken, so the bond dissociation enthalpy will be the least. Then comes bromine, then chlorine. But because fluorine, the atoms are small, so there are lone pair of electrons, there is big repulsion, so the bond breaks easily, very easily, and so the bond dissociation enthalpy is less than that of chlorine. So chlorine has the highest bond dissociation enthalpy. So then after chlorine, bromine, then comes fluorine, and least is iodine. So option D is the correct answer. Chlorine is more than bromine, is more than fluorine, is more than iodine. When copper is heated with concentrated nitric acid, it produces, so the reactions are copper with nitric acid will form copper nitrate and nitrogen dioxide along with water. So option C, copper nitrate and nitrogen dioxide is the correct answer in addition to water. Among the following, the correct order of acidity is, as the element is same, so the acidity will depend upon the oxidation number. So in case of HClO, the oxidation number is +1, this is +3, this is +5, and this is +7. So as the oxidation number increases, the acidity also increases. Same element, oxidation number increases, acidic strength increases. This is the trend that you should always follow when the element is same for oxo acids. So HClO is less acidic than HClO2, is less acidic than HClO3, is less acidic than HClO4. Option D is the correct answer. Strong reducing behavior of H3PO2 is due to high electron gain enthalpy of phosphorus, high oxidation state of phosphorus, presence of two OH groups and one pH bond, presence of one OH group and two pH bonds. Option D is the correct answer. The structure for H3PO2 is, it has two pH bonds. These bonds can be broken and it can act as a reducing agent, and it has one OH. So option D is the correct answer. All oxyacids of phosphorus which have pH bond act as strong reducing agents. The variation of the boiling points of hydrogen halides is in the order HF is more than HI is more than HBr is more than HCl. What explains the higher boiling point of hydrogen fluoride? This is hydrogen bonding. So there is strong hydrogen bonding between HF molecules. This is the correct answer. The bond energy of HF molecule is greater. That does not explain the boiling point. Effect of nuclear shielding is much reduced in fluorine, which polarizes. This also does not explain the boiling point. Electronegativity of fluorine is much higher. Electronegativity is higher, but the real reason for higher boiling point is hydrogen bonding. Which of the statements given below is incorrect? Ozone molecule is bent. Yes, it is. O and F is isoelectronic with O2 and negative. So this is 8 and 715 and 924. This is 16 and 723 plus 124. Both are isoelectronic. So this is also correct. We need to know the incorrect statement. OF2 is an oxide of fluorine is not correct. Option C is the answer. It is not correct because fluorine is more electronegative than oxygen. So this is a fluoride of oxygen and not oxide of fluorine. Option C is incorrect statement which was asked. Cl2O7 negative is an anhydride of perchloric acid. Yes, if we from perchloric acid, two molecules, if we remove one water, we get Cl2O7. So option C is the correct answer. The formation of oxide ion O2 negative from oxygen atom requires first an exothermic and then an endothermic step as shown below. The process of formation of O2 negative in gas phase is unfavorable even though O2 negative is isoelectronic with a stable noble gas neon. It is due to the fact that, so the correct option amongst these will be electron repulsion outweighs the stability gained by achieving noble gas configuration. It's a small atom. By getting one electron, even though noble gas configuration is attained, but because the electrons are so close together, they repel the incoming electron to such an extent that you have to put the electron forcibly, and reaction is endothermic. Acidity of diprotic acid in aqueous solution increases in the order. So as the atomic size increases, the bond length increases, bond strength decreases, it's easier to break, so acidity increases. It's easier to break, acidity increases. So as down the group the size increases, so acidity also increases. So H2TE will be having the greatest acidic strength. So option A is the correct answer. Acidity increases in the order H2S is less than H2SE is less than H2TE. This is the trend. Which is the strongest acid in the following? So this is perchloric acid, this is sulfurous acid, so an oxo acid of sulfur and oxo acid of chlorine in a group. Because sulfur, chlorine comes after sulfur, from left to right the acidic strength increases in a period, so the oxo acids of chlorine will be more acidic. Now if we have to choose between HClO4 and HClO3, so when the element is sailed, as the oxidation number increases, the acidic character increases. So option A will be most acidic. This is the strongest acid. Which of the following molecules contain no pi bond? So sulfur dioxide has pi bond, NO2 also has, carbon dioxide also has pi bond, but water has only sigma bonds. So option D is the correct answer. Which of the following does not give oxygen on heating? Potassium dichromate will give oxygen on heating. Ammonium dichromate does not give oxygen. So option B is the correct answer. KClO3 also gives oxygen. Zinc chlorate also gives oxygen. Identify the incorrect statement regarding the molecule XeO4. It is square planar. There are 4 p pi d pi bonds. There are 4 sp3p sigma bonds. XeO4 molecule is tetrahedral. So this is tetrahedral. So this option is correct. So it's not square planar. So this is the incorrect statement. The pi bonds are between p and d bonds, d orbitals of oxygen and xenon respectively, and sigma bonds 4 are also present. So these are correct statements. This is the incorrect statement. This is your answer. In which of the following compounds nitrogen exhibits highest oxidation state? So oxidation state in N2H4 is -2, in NH3 is -3, in N3H it is -1/3, and NH2OH it is -1. So highest oxidation state will be the smallest value because all are negative. So -1/3. So it has the highest oxidation state. So option C is the correct answer. Sulfur trioxide can be obtained by which of the following reactions? So calcium sulfate plus carbon will give calcium oxide plus sulfur dioxide plus carbon monoxide. There is no sulfur trioxide. Ferric sulfate forms ferric oxide plus sulfur trioxide. So this is the correct answer. Sulfur plus sulfuric acid will give sulfur dioxide plus water, no sulfur trioxide. Sulfuric acid plus PCl5 will give first monochlorinated and then dichlorinated product along with HCl and POCl3. So option B is the correct answer. In which of the following arrangements the given sequence is not strictly according to property indicated against it? So this is hydrides of halogen family. So acidic character increases down the group. This is correct. Water, this is oxygen family. So acidic character increases down the group, but what is asked is pKa value, which is inversely proportional to acidic character. So this is incorrect. Option B. It is not according to the property indicated. Nitrogen family hydride, as we go down acidic character increases, so this is correct. And here we have oxidizing power. So oxidizing power is the tendency to gain electrons. As we move down the group, the inert pair effect increases. So tendency to have +2 oxidation state will become greater. So from +4, this will tend to come to +2 oxidation state and show increasing oxidizing power. So this is also correct. Only this statement is incorrect. Oxidation states of phosphorus in H4P2O5, H4P2O6 and H4P2O7 are respectively. So, and this is 5 into -2 -10. This is +4. So this is -6 divided by 2. This is +3. H4P2 is O6. This is -12. This is +4. So -8 divided by 2 minus. This is +4. +8 divided by 2. And in this case it's 14 and this is divided by 2. We get 5. So it should be +3, +4 and +5. Option D is the correct answer. The correct order of increasing bond angles in the following species is Cl2O is 111, ClO2 is 118, and ClO2 negative is 105. So this is smallest bond angle. So 105, 111, 118, option D is the correct answer. How many bridging oxygen atoms are present in P4O10? To find out the bridging oxygen atoms, we have to write down the structure. So this is the structure. 4 phosphorus are linked to each other through oxygen atoms. So 1, 2, 3, 4 oxygen atoms are acting as bridging ligands, and also this oxygen and this oxygen. So in all there are 6 bridging oxygens and 4 double bonded oxygens. So option A, 6 bridging oxygens in P4O10 is the correct answer. Among the following, which is the strongest oxidizing agent? So which can gain electron very easily will be the strongest oxidizing agent. Fluorine is the strongest oxidizing agent among the 4. Option D is the correct answer. The angular shape of ozone molecule consists of 1 and 2 sigma bonds and 1 pi bond. 2 sigma, option B is the correct answer. Which one of the following order correctly represents the increasing acid strength of given acids? This is HClO2, HClO, HClO3, HClO4. So increasing acidic strength is for this compound. Then we have this, then this. Option D is the correct answer.